Hello. Today we have not only Pre-Calc Lesson 14, but a change of pen color. Orange is the new color for today. We're going to talk about sine, cosine, and tangent, which is a review of Algebra 2, angles of elevation and depression, rectangular and polar coordinates, and coordinate conversions. So, let's first talk about SOHCAHTOA, sine, cosine, and tangent. We know that the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Okay? This is what we have been doing for a long time. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now, in our triangles, okay, this is something that people struggled with yesterday. We can only use this if it's a right triangle, no other triangle. And if this was my theta, then this is my hypotenuse, this is my opposite, and this is my adjacent. Adjacent is sharing a side with the angle. Hypotenuse is always the longest leg and always across from the right angle. And opposite is opposite. Okay, so let's do a couple examples. Make sure we're all up to speed. In this example, if I want to find this angle M and X, this is 3, this is X, okay? I can first find X by using the Pythagorean theorem. X squared plus 3 squared is 7 squared. So X squared is 49 minus 9. X squared is 40, and so X is the square root of 40. Okay, now I'm going to use 3 and 7, not what I just found for X, to find M. I know that I have opposite and hypotenuse, so the sine of M is opposite over hypotenuse. Now, a big mistake people made is they divided by sine. You cannot divide by sine. Sine is a function acting on something, not a number. Instead, I say M is the inverse sine of 3 over 7. This is something that you do in your calculator. You can't do this in your head. If you don't know how, come and see me in student hours. And this gives me that M is 25.38. Okay? That gives me M and X. Okay? Now, let's move on and talk about angles of elevation and depression. Okay, so your angle of elevation, it is measured up from the horizontal. So if this is my horizontal, this right here is my line of sight. This is my angle of elevation. Okay, angle of depression, this is measured down from the horizontal. So if this is my horizontal and this down here is my line of sight, this is my angle of depression. Okay? So, let's just jump right into an example. A man 6 feet tall is 200 feet from a tree. And he measures the angle of elevation to the top of the tree as 11 degrees. How tall is the tree? So first things first, you should always, always, always draw a picture. So this is my man, and he is 6 feet tall. And he's standing 200 feet away from a tree. Okay, now this is the key. This is his line of sight from his eyes. Okay, and he says we have an angle of elevation to the top of the tree, which is this right here. This angle is 11 degrees. Okay, and we are looking for this distance. We can call it h. Now I know it's not exact. It says the man is 6 feet tall, and we don't measure up to our eyeballs only. But in perfect, fun, pretty math land, that's how we're doing it. Okay, I know that this is 200 feet, same as it was on the bottom. So I'm going to use tangent. The tangent of 11 degrees is opposite over adjacent. So that h is 200 tangent 11. But that's just the height of this fluffy portion of my tree. I want the height of my whole tree. My whole tree height is going to be 200 plus h. So my tree, I'm sorry, not 200, 6, it's getting ahead of myself. My tree is 6 feet plus 200 tangent 11, which gives me about 44.88 feet. Okay? Yes? Okay, let's do another example. An airplane is flying, as they typically do, at an altitude of 3,000 feet above the ground. The pilot, with his good eyes, sights an object on the ground at an angle of depression of 26 degrees. What is the slant range from the airplane to the object? Okay, so again, first things first, draw a picture. There's my plane, and the plane is 3,000 feet above the ground. So this is my ground. This is my object. My pilot sights the object here. Okay, and this is, I'm going to call S my slant range. Okay, now here's the tricky thing. My angle of depression is this angle right here, 26 degrees. We want this angle, okay, to be able to find my slant range. Okay, so all I do is theta is 90 minus 26, which gives me that theta is 64. Okay, so then I have the adjacent. I want the hypotenuse. So I can say the cosine of 64 is adjacent over my s. Multiply both sides by s. So I get s cosine of 64 is 3,000. Divide by the cosine of 64. So s is 3,000 over the cosine of 64, which gives me approximately 6,843.52 feet. That pilot has very, very, very good eyes. Okay? All right. Moving on, let's talk about rectangular and polar coordinates. Okay, rectangular coordinate is the distance right or left of the origin and the distance above or below the origin. And we can write it as an ordered pair or a vector using I hat and j hat. Okay, polar coordinates are a directed distance and it is an angle counterclockwise from the x-axis, that's my theta, and it is written as an ordered pair r theta or r theta, like that there. Okay, now for coordinate conversion, if we are going from rectangular to polar, you need to draw your graph, always and forever, determine your hypotenuse, and then determine your angle. Okay, so here's an example. This is example 3. We're going to convert -3 to polar. Now we know this is -3 I hat plus 2 j hat. Okay, we first graph it. We have -3, 2, which means I have this triangle. This is 3, this is 2. And I can find my r by using the Pythagorean theorem. R squared is 3 squared plus 2 squared. So r squared is 9 plus 4. So r squared is 13. R is the square root of 13. Okay? And I can find my theta, right? I can find my theta by using tangent. This is my theta. I know that the tangent of theta is opposite over adjacent. So theta is the inverse tangent of 2/3, which I did not bring my calculator. Let me grab it. I have the inverse tangent of 2/3, and it gives me about 33.69. That is not my theta though, okay? Because I am in the second quadrant, I started at 0, and I've gone this whole distance, so my final theta is going to be 180 minus 33.69, which gives me 146.31. Okay? So my polar coordinate is the square root of 13, 146.31, or depending on how you are asked to write it, 3.61, 146.31. Okay, now something else that we are going to talk about is there are different forms of our polar coordinates. Okay, we can write it also as the square root of 13, 146.31. We can also look at the negative angle. Okay, 146.31 degrees is the same thing as negative 213.69 degrees. So we can also write this as the square root of 13, negative 213.69, or the square root of 13, negative 213.69. Any of these forms would be acceptable. If you see where it says write it in 4 forms, this is 1 form, 2, 3, 4. Those are our 4 forms. Okay. Now let's talk about going from polar to rectangular. Okay. Again, first draw your graph. Find your adjacent side. Then find your opposite side. So, example 4, convert negative 13, negative 253 to rectangular. Okay, so I first am going to draw my theta. Negative 253 means I'm going to go this direction, and it puts me here. This is negative 253. Now I can do 253 minus 180, which gives me 73 degrees, which is right here. Now, this negative is going to bring me across my origin, so my final graph will be in the 4th quadrant. My hypotenuse is 13, and I have 73 degrees in here. Now, the different origin place is important because for our sines, we have all studs take calculus, which tells us the sign of our cosine and sines. So here we always know that x is our cosine of theta, y is our sine of theta. So x is 13 cosine of 73, and y is 13 sine of 73. But because we're in the 4th quadrant, we know that cosine is positive in the 4th quadrant, but sine is negative. Okay, now I'm going to find these values in my calculator. I will have 3.80 I hat minus 12.43 j hat. Okay, that is converting into rectangular form. Okay, as always, if you have any questions, please bring them to class tomorrow and we will go over them. But that is all for now.